Today's lesson is lesson 3.3, equations in y equals mx form. Once again, copy the work onto your toolkit. What will we learn today? To write and solve direct variation equations, and to compare direct variations by using equations or graphs. 3 vocabulary words for this lesson: direct variation, constant of variation, and constant of proportionality. And a side note here regarding y equals mx. In a direct variation equation, y equals mx, m represents the constant of variation, the constant of proportionality, the slope, and the unit rate. So that m represents all of those 4 items. So direct variation, what is that? A linear relationship is a direct variation when the ratio of y to x, here's my ratio y to x, is a constant m, or equal to m. And again, m represents our slope, our constant, and that does not change. So we say y varies directly with x. In symbols, m equals y over x, or we can say y is equal to m times x, where m is the constant of variation and m does not equal 0. So an example, y equals 3x. So the 3 is our constant, also our slope. What it's telling us is that no matter what, no matter how far we get into this line, we will always be going up 3, 1, 2, 3, and over 1. 1, 2, 3, over 1. That's why it's called constant. It does not change. It will always have that constant or slope of 3. And we'll be looking at some examples in the following screens. For our first example, we're going to see a real-world example. The amount of money Robin earns while babysitting varies directly with the time as shown in the graph. Determine the amount that Robin earns per hour. Okay. So we can see that our x-axis represents hours, or time in hours, and the y-axis represents amount earned. So we can create a table. So we'll say time, that's our x, and we can say amount, and that's in dollars. Okay. I'm looking for my what I call my perfect points. There's a perfect point because all 4 of these boxes here, the line meets right in between all 4 of those boxes, or 4 units. So I continue on and I see another one there. Okay, so this point, my x is 2, my y is right in the middle of 10 and 20, which is 15. And then I look at my next one, x is 4, then y is 30. Okay. And I can see that my constant is changing, adding 15, adding 2. We take y over x like we did in lessons 5.1 and 5.2. My y is 15, my x is 2. 15 divided by 2 is 7.5. Now we're talking about the amount that Robin earns per hour. So this is going to be per hour. This is 7.5 over 1. So we're going to say she earns not 7.5 but $7.50 per hour. So in the complete sentence, Robin earns $7.50 per hour of babysitting. Example number 2, another real-world example. A cyclist can run 3 miles in 0.25 of an hour, or in a quarter hour. Assume that the distance biked in miles y varies directly with the time in hours x. In other words, that what they're trying to tell us is that the miles, which is represented by y, varies directly with the time in hours x. So it's not going to change. We're going to have a constant rate. And we know it's 3 miles per every quarter hour. This situation can be represented by y equals 12x. Graph the equation. how far can the cyclist ride per hour? So they want us to do two things. First, we're going to graph it, and then we're going to answer the question how far he can ride per hour. So in order to graph this, we need to create a table. And my table is going to look like this. Okay. I'm going to have my x value, which I don't know what my x value is yet. I'm going to have my equation or my direct variation, which is y is equal to 12x. And then I'm going to have my y. And so then let's plug in some numbers for x. My x is my independent variable. Okay, that's going to change. But my y is going to be dependent on what my x is. And I'll show you what that means. So y is equal to 12 times 0. So in order to get our y, we have to multiply 12 times 0. And that obviously gives us 0. So y is equal to 0. We cannot get y without the x. I can come up with any x that I want. I'm just going to stick with the 1. Y equals 12 times 1. That's equal to 12. Now my x represents hours. Okay. They want us to know how far the cyclist can ride per hour. So we already have that right here. In 1 hour, the cyclist can go 12 miles. So in 1 hour, the cyclist can ride 12 miles. But they're also asking us to graph it. Now we didn't need to graph it, but we didn't need to graph it to solve the problem, but we're going to graph it anyways, because that's what they're asking us to do. Obviously, it's going to be in the positive quadrant, and I'll say x is my time, and it's in hours. Y is the distance. And it's in miles. So when I'm going to graph this, I'm going to, obviously there's 0, 0. And for 1, it's going to, we'll go up by 12. So we can do that. 12, 24, 36. For our time of 1, 2, and 3. So let's go ahead and plot the 1, 12. So in 1 hour, it's 12 miles. And that's going to continue. So if I go up 1 more hour, it's going to be another 12 miles. That's going to be my next point. And then again, going up 1 hour, it's going to be up 12 miles. That's my constant of variation. It's going to continue increasing 1 hour, 12 miles, 1 hour, 12 miles, all the way through. And that's the graph that represents y equals 12x. The key concept for this lesson, compare direct variations. You can use tables, like you see here, here's a table, graphs, words, or equations to represent and compare proportional relationships. And we're going to be looking at that in the next example. Example 3. The distance y in miles covered by a rabbit in x hours can be represented by the equation y equals 35 times x. So that's for the rabbit. The distance in miles covered can be represented by y. Y is the miles that the rabbit's going to cover, and it's 35 times x, where x represents the hours. The distance covered by a grizzly bear is shown on the graph. So now we're looking at the grizzly bear. Which animal is faster? So they want to know which animal between the rabbit or the grizzly is faster. Now, let's look at the rabbit first. The 35 is our constant rate. So what that 35 is telling me that the rabbit is traveling 35 miles per hour. Okay? That's the rate that it's traveling at. The grizzly, we're going to need to look at our graph. And in our graph, we see that the x is by hour. So we have 1 hour, 2 hours, 3 hours, and 4. But we just need to know 1 hour since we have the 35 miles per hour for the rabbit. So for 1 hour, the grizzly travels 30 miles. Now we compare 35 or 30. Which one is greater? And in essence, giving us which one's faster, while the 35 is greater. So the rabbit is faster because 35 miles per hour is faster than 30 miles per hour. Again, the 30 miles per hour is what the grizzly is traveling. So that's how we know that the rabbit is faster, because we have the 35 miles per hour. Our next and last example, example 4. A 3-year-old dog is often considered to be 21 in human years. Assume that the equivalent age in human years, y, so human years is y, varies directly with its age as a dog, x. Write and solve a direct variation equation. So we're going to write and solve a direct variation equation to find the human year age of a dog that is 6 years old. So direct variation equation is y equals m times x. Okay. So we know that the y in this example represents human years. And the problem tells me that this dog is 21 in human years. So let's replace y with 21. And we also know that x is dog years, and this dog is 3 years old. So I can replace x with 3, and m stays the same. Okay, that's going to be our rate that we're trying to find. Now, in order to find this, just like we've done in chapters 1 and 2, we are going to divide to isolate this variable. And even though the variable is in front, I'm not going to move it around. I just know that I have to divide by 3, again, to isolate the variable. So I divide 3 divided by 3, I get 1. So I'm left with m equals 21 divided by 3, which is 7. So in other words, it's going to be 7 human years per 1 dog year. So my direct variation, so now the second part is write and solve a direct variation to find the human age of a dog that is 6 years old. So now I'm going to take that 7, I'm going to take y is equal to 7. Okay, I got the m from doing this equation over here. So now 7 times x. And the information they're giving us is the dog is 6 years old. So that 6 is going to be substituted into the x because x represents dog years. So we're going to have 7 times 6 is equal to y. And again, y is human years. So once we solve this, we're going to see that the dog is going to be 7 times 6, which is 42. So the dog will be, excuse me, 42 human years old. So again, direct variation, y equals m times x. Anytime we see that phrase, write a direct variation equation, or anything that has to do with direct variation, it's y equals m times x. They gave us the y, 21 years. They gave us the x, 3 years, to help us find the m. And we needed that to solve for 6 years for a human dog.